So because sine is an infinitely repeating function, for that equation down below, there's going to be an infinite amount of solutions. It's going to keep going and going. It's going to keep repeating. So we'll keep having values for x that you could plug into the sine function and get out square root of 3 over 2. And again, it's because of that infinite oscillation. To find out what those are, let's do probably something you've already done in your course. Let's find out the angle in radians, such that if you do a sine ratio, an opposite over hypotenuse ratio for that angle, you get a square root of 3 over 2. And if we're thinking about positive square root of 3 over 2, if we're thinking about positive square root of 3 over 2, sine is positive in the upper right quadrant and in the upper left quadrant. All students take calculus. That's the way I usually teach students to memorize where sine, cosine, tangent are positive. All are positive here. Just sine is positive here. Cosine's positive here. Tangent's positive here. And cosine's positive here. So to make a square root of 3 over 2 ratio for a sine, this needs to be square root of 3 over 2 for the opposite of each reference angle. So that means that this is a 60-degree angle, or in other words, pi over 3. And so likewise, this is pi over 3 over here. So from the initial side to the terminal side, that's 2 pi over 3. 2 pi over 3. So we got our two answers. Is 2 pi over 3 for radian measurement, and then pi over 3 for radian measurement. Make this be true. If you plug in pi over 3 in the calculator, sine pi over 3 gives you square root of 3 over 2. So to find all the real numbers, meaning listing all the infinite amount of numbers that make this equation be true, we'll start with listing the first one. We'll say that x equals pi over 3. But now we'll use the fact that sine repeats every 2 pi, and it starts doing the same exact thing. So we're going to say x equals pi over 3 plus 2 pi times some k. And then we'll just have to make a note that k is an integer, and that's where you can use this notation. It's shorthand to say that k is an integer, where the z with I think it's a Greek letter, but the z with a funny little line going diagonally, with the double line going diagonally, means that the set of integers. So k could be 1, then you'd just do one revolution, you'd have the same thing. K could be 2, and then you'd be on a double revolution. K could be 3, k could be 4, k is an infinite amount. So that's one of our solutions. And you just do the same thing for the other one. We said 2 pi over 3 was the solution. We're going to add plus 2 pi k again, because this tells us that we have another solution every time we do a full rotation or we do a full oscillation and come back to the beginning. Plus 2 pi, plus 4 pi, plus 6 pi, etc., etc. So these are your two infinite amounts of solutions. That describes all the possible solutions to this equation.